All right, all right. Welcome to CHADEV. Glad everybody's here with us today. Next week, we don't have a talk. We do not have a talk. I repeat, we do not have a talk next week. So don't show up next Thursday. We won't be here. But we will be here next Tuesday evening for the annual CHADEV holiday party. And, pardon me, you should all wear your ugliest Christmas sweaters. There may or may not be prizes. Both crowd choice and judge's choice. So come out for that bit of fun. It'll be right here on floor 5. And I believe we start at 7. So come out for that. We'll have a good time. Be light refreshments. It's BYOB. And please do. Please do bring. Let's give a shout out here quickly to our sponsors. Well, Open Table first. What's up, Open Table? Thank you guys for feeding everybody here. These people make sure that you get to put some pizza in your mouth every week. So if you get a chance, get on Twitter and give one of these people a shout out. It's a nice thing to do. These slides are clickable, so some of the things that we'll show you today, some of the links, you can go on to chadev.com/lunch-slides and access these things. You can check out our live stream if you can't be with us in person. Join us virtually on our YouTube channel, where we're live streaming every week. You see right there and there we are. You can wave at that camera. That's the crowd camera up there. And now and forever, it'll be there. Hit us up on various social medias. You know how we do on there. A lot of meetups here. If you have a meetup and it's not here, let us know. You can do a PR on these slides and get that listed. CHADEV survey. This is something to do. If you haven't taken this yet, please do. One of our members is putting this together and using the data to kind of just let everybody know what's going on in the community. You know, how people are compensated and whatnot. Should be some interesting data. We need to get about 90 responses for it to have any statistical significance. So go on there and fill that out. And then once we do hit that, we'll be putting together some sort of infographic or some nice data visualizations, et cetera, et cetera. So that'll be fun. Hit us up on Slack. If you're not there, we're there, and we'd like you to be there. Of course, you can always get on Freenode with us and in our CHADEV org as well. So without further ado, we've got Colin here. Colin's going to talk to us a little bit today about React and Redux, so give him a big round of applause.
All right, hi everybody. My name's Colin. I work for a company called RentPath. It's headquartered down in Atlanta, but we are located all over the country. We've even got a guy working in Nicaragua, so everywhere. We've got about 90 engineers on the team I work with, and we are responsible for building and maintaining a number of sites in the apartment and housing rental market space. So we have a pretty familiar problem to a lot of people, something that a lot of folks face these days. We have a solution to that problem, and I'm going to show you an example of that. So our problem is really a couple big things. One is accessibility. So accessibility is important to us because not everybody has a modern browser, not everybody has a nice new phone. And so we want to be able to support as many devices as possible. We want to provide a good user experience for as many people as possible, especially people that have additional needs or challenges when using the internet. SEO requirements are huge for us. There are a number of competitors in our space, and so everything with us is really focused around SEO, making sure that we're #1 on the Google search results. two big things come into play with that. So one is our initial page load. We need to be fast. People like a site to render quickly, so we want it to render quickly. That helps us out. And then crawling. So a traditional JavaScript web app, as you think about it, is not very crawler friendly, and Google doesn't like that when they're crawling your site. So we need something that Google can crawl and index easily. And then, importantly for me, happy developers. So my job is focused around developer happiness, and so any solution that we come up with, we want to be a solution that makes developers happy. Specifically, we want to write code once, and I want to have better debugging tools for our devs. When I say write code once, so the problem we face is that we have just one of our apps in particular is a Ruby app. It's about 32% of the code base is Ruby. About 22% of that code base is JavaScript in various CoffeeScript, whatever. There's a lot of duplication between the code, particularly with our setup. The way we do caching requires us to duplicate a lot of the views that we render on the server side in JavaScript, like handlebars, templates, for example. And that's a pain in the butt. Whenever you're trying to update code, you've got to go update it in two places. Nobody likes that. So we want to avoid that. And then we want to make it easier if something's broken to figure out what's going on. So a solution. Any solution that we come to needs to have the following goals. So universal JS. You've heard of isomorphic JS, universal JS. You can call it whatever you want. The idea is the same. You write code once, JavaScript, and it runs on both the server and the client. No more duplicating that content in your views. It needs to be easy to reason about. So as I mentioned, we have 22% of our code base for this one app is JavaScript. This is a code base of thousands of lines. So that's thousands of lines of JavaScript. That's not easy to reason about. You click something, now you've got to figure out, all right, now what exactly did that do? How did that affect everything else? And then we want to make it easy for developers to fall into the pit of success. And this is something that Facebook's big on, and I'll talk about this some more. So the technology, and I'm just going to briefly run through all of the kind of the higher level pieces of this and give a quick overview. You can give hour-long talks on each of these, and people have given multiple hour-long talks on all of these. So part one is React. React, for those unfamiliar, is a framework, if you will, developed by Facebook initially, and then by Instagram started helping out with it. And so it was created to solve a particular issue, and that was how do you reason about lots of events being fired on a page and what those events do and what they affect. And then one of the design goals was to help developers fall into this pit of success I talked about. And the idea being that we should build a tool that is designed such that if anybody is using it, whether they are new to it or experienced at it, they can't help but write good code. Like they just end up writing good code. And so that's the pit of success. So we want you to, I don't know what I'm doing, but I still end up with something that's wonderful. So 3 principles for React. It's just the UI. It only touches the UI layer. So if you think of MVC, it's just the view. It's a virtual DOM. So the entire idea of React is that I generate a virtual DOM every time something changes. I generate the entire DOM. And then I compare it to the existing DOM. And I say, OK, just this changed. Let me change that. And now when I say I compare it, React compares it for you. If you're doing the comparison, you're doing it wrong. But React uses some very nice algorithms to effectively and quickly and very efficiently do a diff and then update your existing DOM in place so that you get nice, clean rendering. And because you're rendering the entire state of the world every time, it's very easy to reason about. React also requires that you think in a unidirectional data flow. So data comes in, data goes out. If you want to change something, you pipe it all the way back to the beginning, and data goes in, and then data comes out. So some of the features of React that are very handy. JSX. So JSX is a templating language that Facebook built around React components. It gives you a nice, easy syntax to build React components. React components are actually just JavaScript functions rather than having to declare a function every time you want to build a new component, you can use an XML-like syntax. Dumb components and stateful containers. So this is a kind of a philosophy that's really become really popular in the React community. So as I mentioned, React components are just JavaScript functions. So if you have these dumb components that are just pure functions, all they do is they take something in and they spit out some output, and they don't change any state, they don't have any side effects, there's no mutability in them, then you have a dumb component that's really easy to test. And then you can use these dumb components with stateful containers, which are these kind of higher order components that actually do have state, and they manipulate other objects and do all of the nasty bits that makes reasoning about a large concurrent system difficult, but you've isolated them into a very small area. So, oh, that's really tiny. Okay, so here's a little example of a React component. So I'm just, well, a React component, and then really what makes React really neat with the server-side rendering. So I'm creating a component, and it's just a function, and it takes in some object, and then it's going to access the name value on that object. And then I'm going to render it to a string. And so this is an example of JSX right here. You can see I'm using that XML-like syntax. And so React provides a number of modules that will render React components to string. Being able to render your entire DOM to string means that I don't have to do all this on the client side. I can generate my DOM on the server side, and then I can just respond with that to your request. So I get nice server-side rendering, but if I want to do it on the client side, no problem. I'm doing the same thing. So Flux. Flux is this idea that, all right, we've got this great view part of our architecture. Now we need a way to reason with kind of how data comes into the system and affects the system. And so Flux is an architectural pattern developed by Facebook that, again, uses a unidirectional data flow. And it has three main parts. We've got actions, we have a dispatcher, and then we have stores. So actions are just a way of specifying what happens, and there are specific types that you define. And so there is a known list of things that can happen in your system. Then you have a dispatcher, which receives these actions along with some payload and says, okay, I've got this action, I need to distribute it out to the stores. And it calls out to the stores and tells the stores about what's going on or what just happened. And then your stores are where you keep your state and your logic for a specific domain. So it's not models in the traditional sense of an MVC. This is more domain-based. And so this was stolen from Facebook or appropriated from Facebook and gives you an idea of how an action comes into the system, flows through the dispatcher, into the stores, into the view, and then if you interact with the view, you trigger the whole cycle again. So Flux is an architecture, but it's also an implementation, or 3, or 4, or however many there are today. There are a lot of them. You can pick your own, you can roll your own, whatever you want to do. All of these have a varying number of features and design philosophies. However, I think there's one in particular that is the best Flux implementation that I've come across yet, and that's Redux. And so Redux is a project designed by Dan Abramov, who is pretty active on GitHub. He built it really as a way to come at it, or to get to a better development experience. So he had seen some neat ideas. One in particular was in Erlang. He talked about, he read a book one time about Erlang, and they were talking about how if you have pure functions in your modules, you can swap those out at runtime, and it doesn't matter because it's a pure function. And if you are familiar with Elm at all, Elm architecture has this idea of kind of abstracting time or pulling time and state out of the system. So in building this developer tooling, he actually kind of built an accidental Flux implementation. He wasn't trying to implement Flux. In fact, he originally started working on Facebook's implementation But in order to build the tooling that he wanted, he ended up building Redux. And so Redux has three main principles. There's a single source of truth. So all of your state is stored in a single store, which is very unlike the concept of Flux. The traditional Flux architecture, you have multiple stores, a store for each domain. Redux says, no, we're going to have a single store that contains everything, and it's going to be a tree. And by storing everything in a single store as a tree, we can easily move backwards and forwards in time, and we can easily reason about the entire system. Our state is going to be read-only. So if you want to change your state, you read the state, you change it, and then you output a new state. You don't modify the state in place. And then any mutations are pure functions. And so these pure functions give us the ability to easily reason about the system. And because we have this tree we pass in, we get a nice, a clean implementation of everything. So all this is based on the idea, and this is a quote from Jessica Kerr, immutable data lets us tie our hands to free our minds. So we're putting these restrictions on ourselves, but by doing so, it makes it a lot easier to think about and work with the entire system. So the whole idea of Redux is built around this concept of reducers. There we go. So at the very top of this comment right here, so this comment outline, that's a reducer. It's some function that takes in an existing state and some action and then outputs a new state. If you've used array.prototype.reduce in JavaScript or any sort of reduce method in other languages, same concept. Something, your existing state, something new, new state. And so this is an example of a almost full-featured to-do app reducer. So we're just looking at the action type, and then based on the action type, we're returning specific things, but we're always returning the entire state. And so this is leveraging a lot of nice new ES6 features. So if some of this looks really weird to you, I guess start reading up on ES6. It's pretty handy. And then this is a more fully featured, fleshed out example of that. There it is, all zoomed out. And so you can see, like, that's all you need to implement a basic to-do app in Flux. And there is actually a fair amount of boilerplate here with the case statements, and that's easy to abstract out by using composition. So some of the features of Redux, we get server-side rendering. So just like with React, we get server-side rendering. With this particular Flux implementation and others, we can do server-side rendering because we have the entire state in one little tree, and we can just pass that to React. We get mind-blowing dev tooling. And yeah, okay, yeah, I've seen cool dev tooling. When I get to the demo, if your minds aren't blown, then I'm sorry. Mine was when I first saw this, that's for sure. And then there's a really simple life cycle, like I talked about. This is all about being able to easily reason about everything. So the life cycle for a Redux system, you dispatch an action to the store calls the specified reducer, you combine multiple reducers into a single state tree, if you have multiple reducers, and then the store saves that complete state tree. And that's it. That's the entire life cycle of a Redux interaction. All right, so I'm supposed to have an inflammatory statement, I think. So one piece of tooling that I'm not going to talk about, but you just need to accept this as dogma, is use Webpack. Gulp, Grunt, all those, no, just use Webpack. The demo that I'm about to give is based off of Webpack. There are a lot of really neat features in Webpack that improve that developer experience. All right, so let's look at a demo. So here is a Redux application. So this is just a to-do list, and let's add demo this bad boy. What else needs to be done? I'll need to wrap up this talk at some point. And I don't know, eat some more. All right, so cool. I can mark stuff as done. All right, I can even look at completed. I can look at active. Cool beans. I could open up the console and see some stuff. But instead, I'm going to look at this Redux dev tooling. And so this is a way that I can see all of the actions that have happened and the state at any given point in time. And I can even say, you know what? I really didn't want to wrap up this talk right now. Let's just remove that from the state tree. And so everything else stays, but that's no longer in the state. Or I can add it back. And like if I want to even look right here, so I can look at my to-dos. I can see that I have, you all see that? Is that just barely? So, I have all of my state tree right here. I can see that I've marked it to do. Let me clear this. Okay, so actually I don't want to do that. I can revert all of that. I can save stuff, all because this is a tree. And as you can see here, here's my initial tree. I can click. And it's just storing a couple items to track state. And then as I append to this tree, this list grows. If I had a more complex app, there'd be more higher level items. So it's nice and easy. So no, I cannot trigger an action from this tool. I could trigger an action from the console, though. But generally, it's better to try and trigger actions. This. So yeah, let's go back to here. So no, this is not a tool that I wrote. This is a tool that Dan Abramov, the creator of Redux, wrote. This is what he built basically on his path to building Redux. That's what he wanted, and so then in order to have that, he built Redux. So let's get meta. So this whole presentation actually has just been a Redux application and React application. And so you can see here all of the steps. This is all the state. And so if I want, I can go all the way back, or I can, let me fragment. So now I can scroll through here and all this. I can revert it and jump back to where I was because I committed that state. As I mentioned, this is a React app, so let me get my cursor over here. And so I have Vim loaded up on my my screen that I'm looking at. And I'm just going to add an exclamation point to let's get meta and save it. And it automatically swaps that out for me. It didn't reload the page. It's still the same page. Let me show you. Okay. So if we go back and forth a bunch, we've updated all of our state. We've got a bunch of state changes there. And now I remove that exclamation point. You can't see. There you go. So now you can see that the exclamation point is gone. All that state's still there. I can actually swap out functions even. I realize live reloading the DOM contents isn't that impressive. But if I wanted to swap out the reducers, I could do that as well. All of it is hot reloadable. And that's through React, Redux, Webpack, and the dev tooling. And then just so y'all can see what the to-do MVC looked like. that I was demoing. So it's just a handful of folders. As I mentioned, we have these dumb components, and then we have smart containers. And there's actually just three containers. This root is duplicated for a dev and a prod. If you wanted to compile it for production, you could strip out all the dev tooling. And then let's take a look at our reducers. So here is the entire to-do list. You saw that was a fully functional to-do list. 50 lines of code with basically just lots of case statements. So lots of boilerplate that could be removed. It's simple. It's hard to get much simpler to build a modern web application with all of the benefits that I've listed in a simpler manner. Hard switching. Oh. Lost my Chrome window. Okay, that's great. I was all impressed that I did a live demo and nothing went wrong. Thought that too early. Sorry, I'm trying to. Here we go. Where all those animations get you. All right, cool. So that's it. I'm Colin Rymer. I'm happy to answer any questions you have. Like I said, this is a pretty high-level overview, so if you want me to dive down into something, I would love to talk more at length about it. So the question was, what are the features I like about Webpack? So compared to Gulp, Grunt, etc., what I really like about Webpack is it's very much kind of the Rails idea of convention over configuration. So Webpack has pretty opinionated ideas on how you should do things. I agree with those ideas for the most part. Where I don't, it's not difficult to override them, but it reduces the amount of boilerplate I have to write. And one of the things I really love about Webpack is the hot module replacement. And I haven't seen a similar feature for like Gulp or Grunt. Gulp or Grunt also require that you use Browserify if you want to use any common JS modules, so basically everything that's on NPM. I don't want to have to include another library just to do that. Webpack says, yeah, that's no problem. Webpack's also really good at multiple entry points. So as I mentioned, like with our application, initial page load is really important. And so if I can reduce the amount of JavaScript I have to send to you in order for you to have everything you need, that's great. And one of the easiest ways to do that is just send you what you need and not anything else. If I bundle everything up traditionally, I'm going to be sending you everything. With Webpack and the multiple entry points, I can say, all right, here's the stuff that's shared amongst everything, and then here is what's unique to specific pages, and I can just send that over as you need it. Those probably are the big things. Oh, and local CSS. That's huge. CSS is a pain in the butt when you have a large application and a lot of CSS rules. Local CSS is scoping for your CSS. So I can write CSS for a React component, and nothing else can use that CSS unless I really work hard to do that. Or I can make some CSS global, and then everybody could share it. But if I want to write some CSS rules for specific components, it's trivial to do that with Webpack. Yeah, so the question is, how does this system help with SEO optimization with respect to unique URLs and crawling? So as I mentioned, we can do server-side rendering, and that's really the key for us. We want that nice JavaScript app kind of interaction and performance that you can get if you're on a modern browser. Having a JS app is really nice because you don't have to fetch the entire world every time. But if you're crawling the site, if you're Google's bot, then you don't have that capability. So you need to get the entire world every time. And so what we can do is we can say, oh, you need the entire world. OK, let's render the entire DOM as a string and then stuff that into the response. And when we do that, we can also stuff the initial state or the existing state, the current state, into a JavaScript variable in the script tag. And then when the page loads, if you do have JS and can run everything, then the Redux store, when it initializes, we can grab that data and pass it to the Redux store, so you're initializing with that initial state. So you get page loading, you've got everything. You don't have the page load flash of unsolid content, or you wait for the app to load with a white screen. You load the page, and it is the actual HTML. And then as you're interacting with it, it updates. So that's how we get that's how we satisfy our SEO requirement by rendering the entire page. It looks no different than if you had requested it from a Rails app or anything like that. So, and then as far as additional or as the URL strings, I mean that's Express is a pretty popular Node server, and we just have it look at the URL string and then do whatever it needs to do. React and Redux alone don't really handle updating the URL when you're using the app on the client side, but you can use what I would recommend is Redux Simple Router. There is another one called Redux Router. The authors of it even say, nah, just use Redux Simple Router. And it works with React Router to actually update the URL in your browser through the History API as you're interacting with the site. Well, somebody else's, yeah. Somewhat. So the question was, is there a clean way to handle where you have to fetch data on both the server and the client side? So since this is JavaScript on both sides, and we're really sharing the same logic, the only difference is calling React DOM or React Server DOM render to string versus React render to string. We can use so in Redux parlance, middleware, and use promises to make those requests, and then once we get the results back, process those requests, and then shove everything into the store or into the reducers. And so Redux makes it really easy to compose your reducer with those middlewares in there as you need them. And so then, because you're only writing that reducer creation once, and that's being shared with both the client and the server, it makes it nice and clean, easy to deal with.
So is there some spot at which, like, when you actually need to fetch the data, you have to do a check to see if you're on the server or client and fetch it from the right place?
You could. I would say just structure your API so that you don't need to do that. Basically use a proxy. And that's a pretty common pattern with universal JS Redux apps, is to have your application server run a proxy that handles all the actual requests, and then you just hit that proxy, and then if you're on the server or the client, it doesn't matter. Yeah. So, yeah, so the question is, if you're passing the entire DOM from server to client, does that do you incur any additional overhead or any performance issues? Is that, yeah, okay. So no, more or less. So the regular request where you're generating the entire DOM and responding to the client, that's no overhead. I mean, that's the same as doing it in any server-side application, Rails or PHP, whatever you're using. The re-rendering of the DOM, yeah, if you do really dumb things, you could incur additional overhead. It's tough. So when you re-render the entire DOM, there are ways where you can specify, like if something is really computationally expensive, hey, like only re-render this if this is flagged, basically. So you can say, here's when I'll need to re-render. Otherwise, you can just assume whatever you have for me is good. And then the React implementation, they've actually done a lot of work on the algorithms they use for both diffing and then how they store the virtual DOM. And so because of that, unless you have a huge difference between the virtual DOM and the actual DOM, you're not going to see much performance overhead.
Is there a concept of partial page refresh? Like instead of sending the entire DOM, can we send a part of the DOM and the server can refresh it, send it back to client?
Yeah, so not with React. Well, yes, with React you could do that. It would be a lot of extra work, and you'd lose a lot of benefits of React. So one of the kind of core principles of React is that you re-render everything. And by re-rendering everything, it makes it really easy to think about everything, because you don't have to think about, like, all right, what's changed, what needs to be updated. You just say, all right, here's my input state, give me everything I need. Like, give me the whole DOM. It's really similar to how a lot of game development works, from my understanding, where you basically re-render everything constantly. But React is really good then, so I've re-rendered everything. It's going to diff everything and say, you know what, like I actually can just swap out a couple DOM nodes or just insert a DOM node. It'll figure out what the most performant way of updating things is, rather than me saying, all right, just render this list, and then I'm going to worry about inserting the list into place and removing old nodes or whatever. I could do that, but I don't want to.
How does it work if the client-side JavaScript is disabled?
So yeah, if client-side JS isn't an option, then any request is going to act like a traditional HTML request. And so it's going to hit the server with some state. The server is going to say, okay, here's what you requested. Let me calculate what the response is going to be, compute it, and then return the entire DOM as that response. So yeah, if you don't have JavaScript enabled, it looks like regular request response client server model. So.
Thank you.
Yeah. Cool. Any other questions? Awesome. Well, if you want to chat with me about React, one more. Yeah.
So there are a few other options if you weren't using React. Mm-hmm. Probably while we've been sitting here, there have been a couple new ones come out.
Yes.
Is there any feature that could be introduced into some of these other options that would make you jump ship and say React is no longer my flavor of choice? Is there something that's missing in your head?
Yeah. So is there any feature that would make me ditch React and jump ship? Probably it'd be a handful of features. So the generating the entire DOM by string, or any part of the DOM by string, is really important for me. The pure functions is another big one. Probably with those two, I could be like, all right, see you, React, because that's big. So pure functions are really nice in my opinion because of the testing, or the ease of testing. If something is a pure function, it's super easy to test. And then, yeah, being able to render the DOM to a string is critical for us. We've actually looked at Virtual DOM by Google. I'm there's a handful of others, and they all have some really nice features, but they don't seem, and in some cases are more performant, significantly more performant than React. But they don't seem to have all of the little niceties that React has. And so it ends up being more work on the developer's part, which is something I'm trying to avoid. All right, so yeah, if you have any questions about any of this stuff, feel free to hit me up afterwards. I am happy to talk about this stuff. And thank you all for listening to me espouse my views.
Thanks, Colin. Yeah, so next Tuesday, join us Tuesday night right here, 7 o'clock for the annual holiday party with your ugliest sweaters. We won't see you next Thursday. It'll be after the new year before we have another Cha Dev. So until next